Now see the next part 5 of coordination compound. Part 5 of coordination compound. Coordination compound. So see the next part, that is sixth one. The correct increasing order of trans effect of following species. That is called trans effect of the species. Question number 6, it is asked in 2016 in Neet. So see the explanation of what is trans effect. So the intensity of trans effect as measured by the increase in the rate of substitution of trans ligands. So it follow the order. I will write the order of trans effect. It will be cyanide minus greater. It is the most greatest trans effect species. Then it comes C5, C6H5N. Then comes Br minus. Then comes NH3. So this is the first trans ligands. This is the weakest, right? This will be the strong ligands, right? And next will be the weak ligands. Understood? And this will be the order. So please remember the order first. Now see the next sum, 7th. So Chan-Taylor effect is not observed in high spin complexes. So next scientist is Chan-Taylor effect. Right. So it is not observed in high spin. It is talking about not observed in high spin. In high spin. So see the next part, that is 7th. So John Taylor distortion is generally significant for asymmetry occupied EG orbital. So for which it is explained, it is significantly explained for asymmetrically occupied EG orbital, right, as they are directed towards the ligands, as they are directed towards ligands, and energy gain is more, and energy gain is more. So this is told by John Taylor, right? So on the other hand, uneven occupied T2G. So here orbital is in EG, right? This is your EG. And on the other hand, unevenly occupied T2G orbital. So next is T2G orbitals. The John Taylor distortion is very weak. So it will be very weak ligands. Right. So since the T2G orbital doesn't point towards the ligands, so the energy gain is less. And for T2G, it is not directed towards the ligands. Does not point directly at the ligands, right? So thus energy gain is less. So it's a structure, see the electronic distribution. So for it is easy. Next is T2G. So it will be in D4. Next comes D4 means d orbital, right? Next is D7. So it will be in D7. So paired the electrons. So 3, 4, 5. 5 electrons are there in D7. And for D8, it will be 6 electrons. 1, 2, 3, 4, 5, 6. Next is D9. So it will be written as this 1, 2, 3, 4, 5, 4, 5, 6. So it will be in D9. So when D4, then it will be unsymmetrical. So write with the spelling. So it will be unsymmetrical. This is also unsymmetrical. This is also unsymmetrical. This is also unsymmetrical. Right. So this is the John Taylor distortion asked in 2016. So this question is asked in 2016. कहीं भी रहेगा तो change in charge है. Now look at the next sum, that is 8th one. Which of the following has the longest CO bond length? CO bond length, longest bond length. So it is free CO bond length is, so CO bond length it is given, that is 1.128 angstrom. So 1 angstrom means 10 raised to minus of 10 meter. Right. So it is asked in Neet 2016. Now see, the greater the negative charge on carbonyl complex, more easy it would be. Right. So see, the greater negative charge on carbonyl complex, more easy it would be for the metal to allow its electron to participate in back bonding. So higher will be the Mi bond order, larger will be the reduction in CO bond order. Thus, FeCO4 2 minus has the lowest bond order. So it has lowest bond order and hence the larger bond length. So bond order, lowest bond order, then it will be the longest bond length. Longest bond length. I will explain in very simple way. Wait for a second. In a very simple manner, when single bond is there, single bond, right? When single bond is there, bond length is more. Bond length is long. When double bond is there, bond length is double, bond length is small. Bond length is small. When triple bond is there, triple bond. So triple bond means short bond length, right? So it depends on the bond length, how many bonds are uh, associated with that atom or central atom, right? So for FeCO4 2 minus has the lowest CO bond order. So here CO bond order is shortest, right? So hence bond length will be more. So they are inversely proportional. So bond length is more. It is based on mostly theory part. So write the theory part of this question. Now see the next sum, 9th one. So cobalt 3 chloride forms several octahedral complex. So it is nothing but cobalt 3 chloride, right? Forms several octahedral complex. Octahedral complex with ammonia. With ammonia, right? Which of the following will not give test for chloride ion with silver nitrate? So you have to find which will not react with silver nitrate. So it is silver nitrate is AgNO3, silver nitrate. So it is asked in 2015 cancelled paper. So see the explanation then. So I will draw the structure for cobalt chloride. So it will be CONH3 times Cl3. So this does not ionize, so it doesn't give test for chloride ion. So it does not ionized. Ionized means it will not dissociate into plus minus, right? So it doesn't react with, so it does not react with chloride ion. So it will do not react with chloride ion, right? So while others give Cl minus test for chloride, so it will be, so compound will be like this: CO NH3 6 Cl3. It will dissociate into CO NH3 6 3 plus 3 minus will be coming out. In the similar manner, next compound will be dissociated CONH3 4 Cl2 Cl. Then it will dissociate into CONH3 4 Cl2 plus Cl minus. In the similar manner, next compound CONH3 5 Cl. It is Cl2. It will dissociate and form CONH3 5 Cl2 plus 2 chlorine coming out, right? So write this example also, which will give the chloride ion test. So this will be the given chloride ion test. This compound will not give the chloride ion test, which I am circling it. So please write it down. Now see the next term, 10th one. Which of these statement about COCN6 3 minus is true? So it is COCN6 raised to 3 minus. So you have to tell the statement which one is correct for this one. So cobalt, see. So D block elements start from scandium, right? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So it is starting from 21, 22, 23, 24, 25, 26, 27, 28, 29. So here we are using cobalt. So its atomic number is how much? It is 27, right? It is coming here now after the iron and before nickel. So cobalt atomic number is 27. So last electronic configuration will be 4s2 3d7, right? And before that argon will be there representing 18 electrons, right? So after losing the 3 electrons, it will be looking like this. So when cobalt 3 plus charge is assigned, so it will be 3 minus, so it will be 24. So atomic number will be 24. So it will be then become 4s0 3d6, right? So as we know, CN is a strong field ligands, told earlier also, right? CN is a strong field ligands. So it will just pair the inner orbitals. So how many electrons are there in d orbitals? 6. So first do the 1 electron to the each d orbitals, right? Then do the pairing. So it will be coming here and this will be coming here. So after the strong field ligands, it is splitted into two parts. Hold for a second. Huh? Right. So due to a strong field ligands, it is splitted into two parts, right? EZ and T2G. So upper part is called EZ and lower part is called T2G, right? So see the pairing. So total 6 electrons are there. So 1, 2, 3, 4, 5, 6. So this will be the paired d orbital. So it will be dxy, dyz, dzx, right? And upper part is called dx square, y square, dz square. So it is not paired. So there is no electron on that. So this whole energy cell is called delta knot, right? So you can see due to a strong field ligands, no unpaired electrons are there. So it is and will be in the low spin configuration, right? So here no unpaired electrons are there. No unpaired electrons due to a strong field ligands. Strong field ligands do low spin configuration. Low spin configuration. So please write it down then. Now see the next one, 11th one. Sum of coordination number. You have to find the sum of coordination number and oxidation number of the metal. Oxidation number of the metal, central metal. So it is Men2 C2O4 Cl, right? So En is nothing but it is your ethylene diamine. Ethylene diamine group, right? So it is asked in 2015. So how will you find the oxidation state? So for M I will take like suppose M, for En it is 2 En is there, right? So I will write here plus 2 En, then 1 C2O4, and overall charge here it is assigned as minus, so minus will be there. So it will be x minus of 2 because En carry minus 1 charge, minus of 2, and 1 C2O4 will contain minus 2 charge, so it equal to minus 1. So x will be 4 minus 1, it is plus 3. X is equal to plus 3 oxidation state. So it is your ON, oxidation state. Now find the coordination number. So number of binding total is called coordination number. So you can just count it down now. So it will be 6. Coordination number is 6. Why it is so? Because En will give the 2 lone pair. So this will be a 2 into 2, 4, and this will give the 2. So 4 ligands shown by the En. En will show the 4 ligands. Yeah, 4 coordination number because we are using 2 and 1 En will show the 2 coordination number, right? And C2O4 the 2 coordination number. So total 6 coordination number are there. So write it on this one. Current is same, voltage is different. लिखा ना उसके ऊपर. Now see the next sum, that is 12. Among the following complex, one which show zero crystal field stabilization, CFAC, crystal field stabilization, asked in 2012, is octahedral complex. It is given by the formula. So CF is, it is nothing but it is minus 0.4 T2G plus 0.6 EZ of delta node. So for Mn3 plus it is 3D4 manganese. So it will be T2G3 and EZ will be 1. Next is CFSE for Fe3 plus. So it will be given by minus 0.4 into 0.3 plus 0.6 into 1. So it will be minus 1.2 plus 0.6. So it will be minus 0.6 delta. Coming. Next is CFAC for CO plus 2. So it will be minus 0.4 into 3 plus 0.6 into 2. It is equal to 0. You can count it. So next for, so this is for Mn, this is Fe, this is CO2 plus. Next is CD3 plus. So it is 3D6. It is T2G4 Eg2. So CF AC will be equal to 0 minus 0.4 into 4 plus 0.6 into 2. It is equal to minus 0.4 delta naught. So please write the explanation. That's all for today. We'll meet tomorrow. Very, very 10x